Well, hi, good morning, and thanks so much for joining me here in my shop as Christmas is approaching. Today is the 22nd. Wow. So, I've got, I think, 4 more wax capacitors in this radio. 1, 2, 3, 4. 2 of them are look like they're working at on RF type problems. That's these 2. And these 2 appear to be working on audio. This one is the tone control capacitor. That's the tone control. And this one is carrying all the program material that's going to come out of the speaker through it. So everything is funneled through this capacitor, which is off the volume control here. The purpose of this capacitor is not only to allow the audio through, but to stop DC from flowing through. So I think the next 2 I'm going to do are the 2, let's call them audio capacitors. And maybe I'll start with the tone control one. The tone control was working already. I'm not sure it's worth experimenting too much. I think I'm just going to change it and move on. Maybe this one will do a little more experimenting with, kind of do the before and after type thing and see if there is any before and after for it. So I'm going to pop this guy out and we'll put him on the tester. See how it tests. This is probably a case of where if you have a leaky capacitor, it doesn't really, like a mildly leaky capacitor, it doesn't really make that much difference in the tone. .003. So, lots of snow outside right now, but the weather reports are really basically no more snow till after Christmas. That's just a little bit disappointing in some respects. I mean, a lot of people are traveling at Christmas time, of course, and snow doesn't help that. So whether we're going to have a green Christmas here in the end, I don't know. Temperature looks like it's going to float around 0. Or just about the next few days. Okay, so 50 volt leak test. Does it close the eye? Oh, pop right open. But at 150 it doesn't do anything. So the amount of pressure or voltage on this capacitor is quite low. It's just the basically the ABC voltage pushing on it. That's not much more than that. So you'd have to think, oh, that's interesting. So this popped open the first time I did this. Okay, well it's bad. It's bad for leaking. So that would leak some DC potentially into the radio. Why don't we just take a look at the schematic for a minute and try to figure out what that might actually do. Okay, so the capacitor I'm talking about is this one. 0.005. It's 0.003. So what's on the capacitor? Is there another 0.0? Oh, okay, wrong capacitor. This one here. 0.003. So he's got on him a tiny amount of voltage through this huge resistor here. Oh, that's the tone control one. What, did I cut the tone control out? I did. What am I talking about? Tone control. Right on. I'm with it now. So if this guy's leaking, what can it possibly do? He's got a great big... Well, it depends where you set this control. So let's say we set this control up here. That's a maximum treble cut. Then all you've got is this capacitor and its leak right on the screen. So that would draw current, tiny current through the leaky capacitor. That'd be drawing it through this gigantic resistor. 5.6 mega. Wow. I encountered a really big resistor in the last radio I worked on. I was kind of floored by the size of it. This one's kind of a flooringly big capacitor too. So if you draw any current through here, excuse me, you're going to pull the voltage down on the screen. And that's not the screen, that's the grid. this. It must be built up on the... There's a couple of different DC paths. Oh, that's interesting. Kind of a weird combination. If this guy's leaking and this one's leaking, lots of strange things can happen in here, maybe. Maybe. Huh. It's a good leak. You know, 5.6 is huge. There's a huge leak back onto this line. This is the negative bus here. So I think in the end, all I can say is a leak in this one might, if you turn the volume control, tone control to one end, you might find the radio gets quieter. So we can look for that. Of course, I took the stupid thing out. We can't look for that now. And on the audio one, if there's a leak there, one thing I've heard, literally, is a little bit of DC leaking through this control, and when you adjust it, you'll hear and you can't get rid of it because of that's just the effect of DC flowing through there. We get to here, it has two choices, down this way or around this way. It's facing almost 6 megohms this way. There's just nothing, it's just okay, enough of that. Enough of that. Okay, so I've replaced the audio one, gone ahead and did that, and this is it here, 0.05. Let's check it out. So I did have a radio in which the sound coming out of the speaker was like a high impedance grid picking up general noise. That was kind of what was happening. I replaced this capacitor, the volume control slider blocking capacitor. And to my surprise, all that went away. And I really can't explain it. So you never know. You never know. Well, I never know. There's too much to know. There's just too much to know. Isn't that a general truth? Okay. 50 volts, what do? Just like the last one. Didn't quite open all the way. I'm pretty sure it won't open on 150. No. So these are all testing extremely similar. Degraded capacitors. Again, I can't test for its capacitance when it's like that. Okay, so I think what we should do is play this radio at this point just to make sure it's working and get ourselves ready to do the last two capacitors, which I think are a little more interesting. It'll be these two guys which are involved with the RF side of things. So I have the feeling the two capacitors I just did probably won't change the operation or tonal quality of the radio at all. We're all set to go on. Okay, I got the permittive beep from my soldering iron. Soldering iron is talking to me. That's a bad sign when your soldering iron starts talking to you. That's for sure. Take a moment and clean it up just a little bit here. So I do have a signal generator going in here at 600 kilohertz, and it's energizing this loop back here. Okay, let's put the radio on full blast power, which today is 122 volts. So I do hear a hum of the sort I was talking about. Now I'll be quiet here and just listen. Pretty hard to hear that probably. So what I've done seems to have introduced the very hum that I'm trying to that I was talking about. Let's turn it up. So that hum disappeared immediately upon turning the volume control. So open slider in the volume control. If the volume control slider is skidding over top of dirt, yes, that's paint on my hand from what I was doing yesterday. That was my part of my Christmas gift to my wife, is painting some stuff in our house. So anyways, the slider sliding over, if it hits a dirty spot or for some reason lifts off, now you've got the slider just airborne, and it's not down on this resistance anymore. It's now just up. It's become an antenna. It's an antenna hooked directly to the grid of the first of the audio preamp too. Audio of the in the audio the triode that's in the detector tube. Okay, so that's what that sound would have been. And there's no other sounds whatsoever coming out of here. Come on, radio. Uh-oh. Well, so much for that explanation. I got a bigger deal going on here. What's happened? I've done gone and killed the radio. Wow. What has happened? So the heater's on. Oh my gosh. I could do this all day. My radio quit. What, did I do something really stupid? Probably yes. Probably yes. One thing I did was I changed two parts and didn't do a test in between. Well, how could this be? Well, it can't be this. Cold solder joint? Volume down a little bit. Oh, jeez. It made sound for a moment and then quit. Oh, you little bugger, you. Like, is there anything coming out of that speaker? That speaker is just stone cold silent. Output tube popped. Hey, what's happened here? What has happened here? Let's get the signal tracer going. At some point I'll realize the dumb thing I've done, and everything will be back to normal again. We have no instrumentation hooked up at all to this radio until I do this. Now you might hear a slight hum that's coming from the signal tracer. Okay. We set this to audio, and we're going to listen for a signal at the detector. The two detector. So the detector. Let's listen right at the volume control. Yeah. Oh. Hand on the volume. I just can't make a contact here. Oh! Okay. Cold solder. Man, I really? Come on, I really soldered that. At least I thought I did. I thought I did a really good job on it. Oh, it went away again. No, there's no way that's cold. What the heck happened there? Okay, back to the tracer. Back to the tracer. On the volume control. Okay, so this is, we gotta have this up a little bit. Let's go on the input to the volume control. Leave the volume down. Can't hear anything out of the radio on my bench. This is what's coming. Whole lot of nothing. Whole lot of nothing. Whole lot of nothing. Okay, let's go back another step to the detector output. And on the volume. What gives with this radio here? You know what it sounds like? It sounds like a loose tube, in fact. Something coming and going. Holy smokes. Oh my gosh. Hey, it's a job for the stick. Yes, bring out the stick. Volume up fairly high. Just a coincidence? Oh! Okay, so did I say something about bad contact inside here? That doesn't seem right. That seems pretty reliable. What the heck is it? I don't know. It's gone for now. Whatever the heck it is. What is it? Okay, how did this do it? Oops. Okay, I don't know. Don't know what that was. It's gone now. I fixed it. We'll move on. Oh, let's hear some stations here. There's my signal generator. Sounds nice. Let's give it, that's 1,000. This is 400 hertz. Sounds pretty good. Give it a more stronger signal. Sounds a little hard-edged to me. Doesn't sound pure. Interesting stuff. Okay, now it's all working. We're in good shape. Power off before I forget. Last two capacitors, what are they doing? One is connected to a terminal on this IF can, and the other one is connected to a tube terminal here, which in fact comes around on a red wire and ties to another terminal of the same can. So maybe we can see two capacitors off this can. This is the let's see, this must be the first IF can. So look at the first IF can on the schematic and see if we can figure out those two capacitors. Okay, so the first IF can is this one, and the terminals are all around here. And down here's two right here. 2.05s. Grounded. This is a ground terminal here. So, but they're not actually really connected to here. They're connected to these lines. So this 0.05 is on the plate circuit. It's on the B+. And this is the controller of the ABC rate. Yeah, yesterday I did this one, and then later when I was in bed last night thinking about this briefly, I thought maybe there was a big resistor in between here. Oh, Who's at the door? No, it's my buddy Peanut. Come and ask me to play with him. So getting back to these two guys. So both of them appear to be doing the same thing, which is RF, not this one. This one. This one might be RF quieting on the B+. On the B+ line. This one, this is, I believe, the ABC timing capacitor. It's on the far side of the big resistor here. So, oh my buddy. Okay, hang on a second. I'm almost ready here. So we should change these one at a time and see what happens. The one that's more likely to have a noticeable effect, I don't know, maybe this one. It's a fairly large, 0.05. It's busy doing things, you know. This is to stop feedback and all kinds of other stuff that might happen on this line. And we don't have that problem in the radio. But that's the first one we'll go at. The very first thing I have to do is play with my cat here. Peanuts, once again, it's playtime, is it? What game do you want to play? You want to go out there? Is there something out there? Hey, Peanut. Come on. You know what he's asking for. Spring. Can you bring Spring? God, he wants to go somewhere. Okay, I gotta go with him and play. Seems to always be the case. So, the next capacitor will be one of these two. I'll have to sort out which one it is. Let's see what happens. Okay, so as often is the case, it took me a fair bit of time to be absolutely sure which of these two capacitors is which on the schematic. And then suddenly, boom, clear as can be. This is the ABC damping computer, ABC time constant computer, whatever computer. Calculator, holy smokes. Where's my coffee? Capacitor, oh my gosh. So this is the one that's kind of parallel with this one, except this smaller one is tied to the chassis at this terminal connection here. So there's a capacitor from this point to the chassis and from this point to the minus, the B minus. I was going to say the minus B plus. Just more sign that coffee is needed. There should be a 0.05, yep. It was this way. It's pretty roasted. Let's check him out. Check him out. So if this guy was leaky, he's bound to be leaky. I mean, why would it be any different from the rest? You know, in the worst case, obviously, it becomes more of a resistor than a capacitor, and that's a different component altogether in the circuit. 50 volts. Oh my gosh, he's a bad boy. That's a bad boy. So I would pull down the ABC voltage a bit. Not store the charge that it's supposed to store, so the damping effect is not what it could be. Can't help the performance of the radio, that's for sure. So let's stick a new one in, 0.05. Okay, let's turn them back on now and see how well it's doing. Turn off my signal tracer and get rid of the hum from it, on the assumption this is going to work. It's just very slow. Slow. Signal generator, signal. Sounds nice there. Turn this up, it's still got that. It sounds to me like it's modulated with a hum. Very, very hard to see, but to me it has a bit of a hard sound to it. And we hear that. Okay, I don't know if you can hear that in the video or not, but there's that open grid sort of sound. It seems to remain. Okay, but the radio's working. Good. So what's left is one capacitor. Now, what this capacitor does, I'm anticipating putting my scope on this. This capacitor is quieting the, I believe it was the B+. We're going to find that out by looking at the voltage across it first. And he's connected right here. So I say there's 100 volts on it. Seems a little low, eh? 100 volts on the B+ line. That would be the voltage that's going to the plates and screens of the tubes. We have a full supply voltage, 122 volts. Okay, so what we'll do is we're going to put a scope right on this terminal where the capacitor is connected and see what we can see. Let's see what we can see. What do we see when we look in the scope camera? We see a bunch of lights. More lights. Okay, that took care of the lights. Okay. Good. So the scope is currently connected to absolutely nothing. So what we're going to do is we're going to hook it up right across that capacitor, basically. Make sure this is on times 10. The other end of that capacitor is right here. Now, it should jump off the screen there. What am I on? I'm on it pretty sensitive. There are 2 volts per division. Would it probably jump right off? Okay, I think I can hook it this way. Okay, nothing extremely exciting there on the scope. My clip gonna fall? The scope lead. So what I'm thinking I should see here, well, if it's a good capacitor, you should see nothing, right? It should just knock it down to nothing. Here's what's on there. So far, pretty much a straight line. But let's make this more sensitive. Oh, there's that lovely hum. The part I'm interested in is how wide this line is. Let's tune around. I'm not sure what to expect here. Okay, so well, it's behaving like an ABC, isn't it? I'll put this on DC. Where'd you go? Right off. Okay, we're going to zero it. Oops, not with that. It's on the 0 line, DC, 1 off scale, 5 volts per division, 100 volts, same reading as the, there, I don't have to compete over that, same reading as a voltmeter. So when you're looking at it this way, you really can't see anything in that line at all. So it seems like it's actually quieted down. Now we did see a tiny amount of RF there. And did I get confused? And this is the AVC capacitor? Shouldn't be. Why the fluctuation? I'm going to tune the radio again. Why? Oh, there's not much fluctuation. Let me get the signal generator tuned in here. So if that's a B+, I don't think it should be varying like that as I tune the radio. That's definitely not the AVC. The AVC is not riding on 100 volts. Okay, so if I expand this out now, let me put it back on AC and expand it out, way out, way out. We see this. Move it down a bit. You can see what is a little bit of RF in there. I think that's what that represents. Ignoring the hum again, I'll change that capacitor and we'll see if this changes. Maybe the hum will go away. Who knows? Okay, I'll get in there and I'll change that capacitor. Okay, here it is. It's a 0.05 as expected. Let's give him a test. Can he stand up to the pressure? Because this guy lived with 100 volts on him. Maybe even been a little more in the early days. I'll adjust the camera in a sec here. Better view. There we go. Okay, the eye. 50 volts. Just barely opening. No reason to do any more testing on this guy. Leaky like the rest. It would be interesting to know, well, what if you put a ohm meter on something like that? What can you expect to read? Well, in fact, that guy over there is an ohm meter, but we're going to do it over here. I'm going to do it with this one. I'm going to use the clips here. First of all, there's a 1 volt on it. From where? Internal to this capacitor. This capacitor is a voltmeter. Is a battery. .1 volts. So making a resistance measurement on this thing when it's generating its own voltage is just going to be baloney. I would imagine anyway. It's just be malarkey. Something funny with the decimal point on my meter. So it wants to read 40 megohms. Let me switch this the other way. That'll change the EMF coming out of the capacitor here. Don't fall over a voltmeter. Now you get a totally different reading. because the pressure, the voltage inside this battery, yeah, it's a battery, is now helping this meter. That's my theory. Nowhere have I read about this anywhere that these guys develop a voltage, but you know, it's not surprising at all. Exactly where it's coming from is a bit of a question. There has to be two different metals involved to generate a potential like that. So there's a foil in here. What is it exactly? I'm not even sure what kind of foil, what kind of metal it is. Then we have the lead, and the leads are often plated steel or something like that. So there's a couple different metals in here. The battery effect. Now what would that do to the radio? I don't know. In a very, very high impedance circuit, maybe that battery does actually put a little pressure in the radio where it's not needed. But I would think that it's a pretty minor thing. Okay, that's the last paper capacitor done. Here it is here. Got the scope connected. So we're ready to see, you know, what happens to that little bit of RF I saw up there. Okay, power on. Throw on the scope view of things. Whoa. What all is happening there? So why that's jumping up and down on the screen there, I don't exactly know. I need to turn the volume up here. So the radio's working fine. Now there's maybe it's because this radio is not really plugged into a regular outlet. It's plugged into a transformer. I don't know exactly how that would cause it to wander up and down like that. I think it's a problem on my scope, really. Let's see if we can figure that out. What would cause it to do that? Just wiggling all my connections here. This one, you know, I'll show you what I'm doing. So I think there's something bad about this arrangement. Okay, well, regardless of this effect, what we're really interested in is looking at the RF in there. That's what we're interested in, and you know, it looks the same. It doesn't look, to my eye, it looks slightly different, but not enough to. So I don't think we heard anything by doing that, but I'm not sure it really helped out. Let's play the radio now and see what we got for a radio here. I'm going to take this off. Okay, and I left my tracer ground on the B minus there. Take that off. Left my solder laying out here on the bench. Shame. Just throw it over there. Okay, man. Now I hear that again. I hear that metallic hum. I don't know what to call it. Very faintly. May just not be enough to worry about.
Charges, bill hikes, membership renewals, and more. It's just one of the ways we're helping our customers.
Don't you ever get tired of getting your own way?
Let me think. No. You wanted to go to Maple Auto Mall, and here we are at Maple Auto Mall.
Thank you. You wanted this make, this model,
That's the null point aimed at the station.
Personally, I think this sets a bad precedent.
Happy holidays from the Maple Auto Mall. Welcome to Valet by Park and Fly, the easiest and quickest way to park by the airport. Just pull up, check in, and go. A real thing of beauty for travelers. With Valet by Park and Fly, we get your car so you don't have to.
I think that's 610.
Concerned about, and that number one priority of why they would use the TFSA is it matters not about what
640.
tax advantages or disadvantages I have. There are no taxes on a tax-free savings account. So what I find is
I was talking about TFSA. In Canada, we have a system, savings system called TFSA, tax-free savings account, and we're all allowed every year to put a certain amount of money, about $5,000 or $5,500, into this account, and whatever's in that account, we still get taxed on the income. You still pay tax, so you earned your $500 or $5,000. You had to pay tax on it, but you take what's left. Okay, $5,000. You stick it in this account, and whatever interest it earns is tax-free forever. So every year you pump it up another $5,000 or so, if you can do it, if you're lucky enough to be able to do it. And over the course of your life, you can build up a very substantial bank account this way. So it's a very, very important aspect in Canadian retirement, but it only works if you have the money in the first place to put into the account. And we have another system called a registered retirement savings plan, which is a plan where you take some of your income, you stick it in this plan, and you protect it from taxes until 20 years later, when you're retired, you start taking it out. As you take it out, it becomes part of your income, and you pay tax on it then. So one's a tax deferral plan, and the other one is a tax-free plan. So those are the two ways the Canadian government has provided systems for people with money to save it without paying tax, or to have reduced tax or something. But you gotta have money in the first place to do that stuff. There you go. A little lesson. If you're not Canadian, it doesn't matter much. That's going to be 680. So I'm noticing that the pointer's a little high here everywhere. Okay, we're picking something up here. Probably 740. That's really pretty good. The radio pickup 740 here, that's doing pretty good. See if we can get the French station in here.
Essayons de garder ça en tête durant cette période des fêtes. Il y a énormément de période de consommation. Merci beaucoup à vous trois d'avoir été ici. Nathalie Lefebvre, donc étudiante au Cégep Édouard Montpetit, responsable de communication pour la coalition étudiante pour le climat. Catherine Gauthier, directrice générale d'environnement jeunesse. Et Fiona Henry, infirmière engagée, donc co-rédactrice de cette position de l'Ordre des infirmières sur les changements climatiques, Ordre des infirmières du Québec sur les changements climatiques. Merci beaucoup à vous trois d'avoir été là.
No peak. So the last thing I was doing there is I've noticed that on this radio, the trimmer on the RF tuning capacitor is wide open. And it was wide open when I got the radio, and for me, wide open is the best setting. That's not good. I really want a peak to develop here. So I think we're going to we'll go back to the alignment process now. All the capacitors are changed. The only thing that can be retarding the performance of this radio now is the quality of the speaker, resistors I haven't paid attention to, a mica capacitor that's actually gone bad and I don't know it. All those things are fairly unlikely. The most likely thing is a little bit of peaking up on the alignment at this point. Probably just finish this radio off nicely. Great. Okay, that's it for today. Let's see. I think our Christmas company starts showing up tomorrow. So I may have some trouble doing any more work in here for the next week or so, but we'll see. We will see. I'd like to get this guy back in the cabinet at least. Fantastic. Well, thanks a lot for watching again. And hey, Merry Christmas. Hey, what about that hum thing that's in there? What about that? What about that? What about that hummy thing there? See ya.